Hi and good morning class. Good morning teacher. Have you ever wondered what will happen if atoms could talk? That sounds interesting. I have never thought about it. What will they even say? Well, atoms might have fascinating conversations about their need for stability. For instance, a sodium atom might complain about its extra electron, and a chlorine atom might beg for an electron to complete its shell. That does sound fun. But how does that help with understanding ionic bonds? Great question. When you imagine atoms talking, it's easier to see how they interact. Sodium will say, "Take my electron, I don't need it." While chlorine will respond, "Thank you. Now I'm complete." This exchange explains how ionic bonds are formed. Oh, that makes sense. So, it's like a thread between atoms? Exactly. Now, let's watch a video titled, "What Happens if Atoms Could Talk? The Story of Ionic Bond." It uses a fun storytelling approach to explain the concept.
Hey Lisa, long time no see. How are you? Titi, what a surprise. I'm doing well. How about you? I'm good, just ran into a bit of a silly problem. Oh, what's going on? Well, I went grocery shopping and I ended up with an extra egg. My egg container only holds 8 eggs, but I have 9. One's just rolling around and I don't know what to do with it. Funny you mentioned that. I have the opposite problem. One of my eggs broke on the way home, so now my container only has 7 eggs. It feels incomplete. Wait a minute. I think we can help each other out. How about I give you my extra egg? That way, your container will be full and mine will fit perfectly. That's a great idea. Thank you so much. No problem. It works out for both of us. Perfect. My container feels complete now. And yours? All set. It's amazing how such a small thing can make a big difference. You're right. It's like teamwork in everyday life. Thanks again, Titi. It's okay, Lisa. See you around. Imagine there are 2 individuals, Titi and Lisa. Titi has an egg container with 9 eggs, but the container can only hold 8 eggs. Lisa has an almost full container with 7 eggs and is willing to take an extra egg to become fully filled. To resolve this, Titi gives one of her eggs to Lisa. This act balances both the containers. Titi and Lisa have full egg containers with 8 eggs to achieve a stable octet electron arrangement. In chemical terms, Titi represents a sodium atom, Na, with 1 extra electron in its outer shell. It donates this electron to Lisa, who represents a chlorine atom, Cl, with space for 1 more electron in its outer shell. Welcome to the world of atoms, where everything is bonded by science. Today, we bring you a curious story about sodium, Na, and chlorine, Cl, 2 atoms that change their lives forever by creating an ionic bond. First of all, what is an ionic bond?
Ionic bond is formed by the transfer of electrons between a metal atom and a non-metal atom. Ionic bond is a strong bond formed when positive ions and negative ions are attracted by the electrostatic forces.
How ionic bond is formed? Atoms of elements that release electrons form positive ions, and atoms that receive electrons form negative ions. Ionic bond is usually formed between atoms from groups 1, 2, and 13 metal, with atoms from groups 15, 16, and 17 non-metal.
Formation of ions.
Metal atoms donate valence electrons to form a positively charged ion or cation. To achieve a stable electron arrangement, sodium atom Na needs to donate an electron. The process of donating an electron from the valence shell of sodium atom Na is much easier compared to accepting 7 electrons from another atom. After donating its valence electron, sodium ion Na+ achieves a stable octet electron arrangement. Sodium ion Na+ has 11 protons and 10 electrons. Thus, the charge for a sodium ion Na+ is +1. Non-metal atom receives electron from a metal atom to form a negatively charged ion or anion. To achieve a stable electron arrangement, chlorine atom Cl will accept an electron. The process of accepting one electron to the valence shell of chlorine atom Cl is easier compared to donating its 7 valence electrons to another atom. After receiving one valence electron, chloride ion Cl- achieves a stable octet electron arrangement. Chloride ion Cl- has 17 protons and 18 electrons. So the charge of chloride ion Cl- is -1.
Formation of ionic bond.
Oh, whoa, it's me. I have 1 electron in my outer shell and it's making me feel so incomplete. I just want to get rid of it, but I can't find anyone to take it.
Well, hello there, sodium. I overheard your little dilemma.
Lucky for you, I have the opposite problem. My outer shell is 1 electron short of being full and I feel unbalanced.
What happens when 2 atoms with opposite needs meet?
Well, let's find out.
Really, chlorine? You want my electron? It's causing me so much trouble. I would happily give it away.
I would love to take it. With that electron, I can complete my octet and achieve a stable configuration. Here, take my electron.
Oh, much better.
Thank you, sodium. Now I am negatively charged and stable. I'll call myself a chloride ion. And I'm now positively charged and finally stable. From now on, I'm a sodium ion. After this exchange, the sodium atom Na becomes a positively charged sodium ion Na+, because it donates 1 electron to achieve a stable octet electron arrangement. Meanwhile, the chlorine atom Cl becomes a negatively charged chloride ion Cl- because it has gained 1 extra electron from the sodium atom Na to achieve a stable octet electron arrangement. The positively charged sodium ion Na+ and the negatively charged chloride ion Cl- attract each other due to their opposite charges, forming a strong electrostatic attraction force known as an ionic bond. This results in the formation of an ionic compound like sodium chloride NaCl, known as stable salt, with both ions achieving stable octet electron arrangements. We are bonded for life. Electron arrangement of sodium atom is 281. Sodium atom has 1 valence electron. Therefore, sodium atom is not stable. Sodium atom releases 1 electron to achieve a stable octet electron arrangement to form sodium ion Na+ with electron arrangement 28. Electron arrangement of chlorine atom is 287. Chlorine atom has 7 valence electrons. Chlorine atom receives 1 electron to achieve stable octet electron arrangement to form chloride ion Cl- with an octet arrangement of electron 288. Sodium ions Na+ and chloride ions Cl- are attracted with strong electrostatic force. The bond formed is called ionic bond. But wait, what if sodium didn't give up its electron? What would happen then? No, I've decided to keep my electron. I don't trust chlorine. Without your electron, I remain incomplete. And without bonding, we can't form sodium chloride. That means no table salt for anyone. And there you have it. A world without ionic bonding would mean no salt for our fries or pretzels. That's how crucial this process is. And so, we've learned that the magic of ionic bonding lies in the exchange of electrons. Without this process, many essential compounds wouldn't exist. Sodium and chlorine's partnership reminds us that even opposites can come together to create something amazing. Thank you, chlorine. You've truly completed me. And you've made me whole sodium. Here's to chemistry and ionic bonding.
We are bonded for life.